Hello there, I'm Thomas Hatsien, German-American pilot flying the Boeing 787-900 tonight's flight from Zurich International Airport. We're going to be able to fly in Zurich, Switzerland, Germany, then coming back to the Zurich International Airport. Runway 1449, let's localize and landing surrounding the cockpit of the pre-takeoff preparation of quality wings, Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing the cockpit instruments displaying the functions of the Boeing 787-900 aircraft. I'm going to start with the primary flight display. The displays are the airspeed indicated, the airspeed selected from the autopilot and flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the vertical rate of climb descent of the aircraft in tens, hundreds, and thousands of feet per minute, all the steepness of the trigonometric angles in degrees you can climb and descend. Also, we have the altitude indicator over here with the pitch ladder in degrees and the bank angle in degrees, as you can see. So we have also the vertical rate of climb descent of the aircraft 10,000 feet per minute, the stiffness of the trigonometric angles in degrees can climb descent, the barometric pressure of the outside atmosphere, the indicator with the pitch ladder in degrees and the bank angle in degrees. The Lszh localizer, the horizontal localizer, and vertical glide slope that receives the radio frequency from the airport's runways we use for takeoff and for landing. So it displays the horizontal localizer, vertical glide slope because it receives from the onboard antennas of the aircraft and aligns with the frequency with the runway heading and runway elevation. So we have the runway 14 in the Zurich International Airport, the Lszh airport in Switzerland, and you're gonna see how we're gonna use these systems for navigation of the aircraft. I'm gonna show you also the flight mode annunciator. We have the angle of the flight director for manual guidance of the aircraft and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies, and now the flight mode annunciator with the autopilot and the autofollow. Vertical navigation mode. So we have also we have the navigation display. The navigation display that displays the inertial reference position, the GPS position of the aircraft. You can see the magnetic head, you can track the magnetic north pole and true north pole and magnetic variation depending on where we are in the world. We have the terrain map with the weather reflections and also the terrain reflection from the weather radar. You can see the terrain map. We have the location of the airports, also the airport that we are located right now, the Zurich International Airport, the Lszh in Switzerland. So we have also the runways we use for takeoff and for landing. You can see the runway location, its direction with respect to the magnetic north pole or the geographic north pole, whatever we use. We have also the display of the navigation aids, the voice stations, the ADFs, the NDPs, the waypoints which are horizontal and vertical navigation fixes. We have to fly through some waypoints during this flight. I'm gonna use the flight management computer, so I'll show you how to set up a flight plan or a flight path or a route for this flight. Using the flight management computer, I'm gonna input all the data of the aircraft for this flight. So you will see how we're gonna use the flight management computer for this purpose. So we have also the display of other aircraft in the navigation display that fly around us using the transponder, the DSP and ADS-C transmitter receiver that transmits our frequency to other aircraft and the air traffic control and receives from other aircraft, and displays the diamond shape of the aircraft in the navigation display. You can see the altitude difference, the distance they are located, whether they climb or descend with respect to our aircraft, and also you can calculate using the radio frequency receiver. You can calculate the other aircraft velocity with respect to our aircraft and direction, so you can give us a warning, the TICA system, the traffic collision advisory system, to avoid an incoming collision with another aircraft in the air or in the ground. So we have also you can see the terrain map, the terrain elevation around you. With a red, green and yellow color. You can see also the flight plan we're gonna create using the flight management computer, so I'm gonna use the flight management computer now. Also, you can see now it's blank over here. There is no flight plan, either in the HSI or the navigation display. We're gonna use the flight management computer to create a flight plan. So I will input all the data of the aircraft for this flight. That includes the empty weight plus the takeoff gross weight, the empty weight plus the fuel on board, plus the passenger plus the cargo. We have the takeoff gross weight. The fuel on board is the taxi fuel, reserve fuel, and trip fuel. So the flight management computer is gonna make calculations about the weight of the aircraft and the fuel on board in the left and the right wing tank, in the center tank, how much fuel we have, also the loads from the cargo compartments and the passengers. We're gonna calculate the center of gravity of the aircraft for this flight. It will give us also the mean aerodynamic chord position of the wings, which is 23% of the Mach, is the position where the maximum aerodynamic lift occurs in the forward wings, is the position where the stall also will begin in the top surface of the wings when we fly. So I'm gonna show you also the aerodynamics of the flight in a while. So we have also to use 15 degrees of flaps. You can see we can monitor the airspeed here. We can see also the stall speed all the time. If you have a stall, it will give you a red and yellow indication over here in the primary flight display. So we have all these indications. So we're gonna have the flight management computer now to set the flight plan and all the data. So we use 15 degrees of flaps, 33% is gonna be the mean aerodynamic chord position and the center of gravity of the forward wings aerodynamic chord. And this will give us a horizontal stabilizer, the horizontal tail of the aircraft. We're gonna train it all the time during the whole flight from takeoff, climb, cruises, and approach to landing. We need to trim the horizontal tail of the aircraft to balance the aircraft in flight. We can use also the elevator from the flight control system if we need, but we're gonna see how we're gonna train either manually. We can use the switch here in the control wheel. We have a switch to trim the horizontal tail of the aircraft. So you can see here we have the horizontal tail. We can trim it up and down during the whole flight. And also we have the auto trim system from the autopilot flight director system panel, and the auto throttle, which is also a fly-by-wire aircraft, so it trims itself automatically in flight. Also, the aircraft burns fuel during the flight. It will shift its center of gravity in flight. This is recalculated automatically during the whole time. So also now I'm gonna use the flight management computer to input all this data. So the flight management computer also we're gonna give me the runway we're gonna use in the airport, the Zurich International Airport, the Lszh in Switzerland, and the runway 14. We're gonna have the runway length, the runway wind, the runway slope, the wind direction, also the barometric pressure, the density of the air, the temperature of the air, and the flaps I'm gonna use for takeoff, 15 degrees of flaps. It's gonna give us for this mean aerodynamic chord position and center of gravity, 33% of the mean aerodynamic chord, and 4.35 degrees of horizontal trim stabilizer. Gonna give us the takeoff speeds V1, V-rotate, and the V2. Also after the takeoff we have the V2 plus 15 knots, the climb speed, initial climb speed. We have I will insert the seats. The seats are the standard instrument departure waypoints and fixes that include horizontal vertical navigation fixes and altitude and airspeed constraints for the initial departure and climb of the aircraft. I will insert also the top of climb, the cruise level. We're gonna cruise the aircraft like 35, 26, 27, 28, 29, 30,000 feet above the sea level, like 7,000, 8,000, 9,000 meters above the sea. So we're gonna be flying fast over there with like Mach 0.8 or 0.9. You will see also we have the we're gonna transverse through some waypoints in the cruise level. Then we're gonna start the top of descent. We're gonna initiate the descent back to the elevation of the airport, like 7,000 or 6,000 feet above the sea level, and we're gonna align with the stars. The stars are the stellar terminal arrival waypoints and fixes. I'm gonna insert from the flight management computer to complete the flight plan, so that will help us align with the long final, the short final waypoints and fixes, and airspeed and all the constraints of the runway. The Zurich International Airport, runway 14 again in Switzerland, the Lszh airport. We're gonna use again the runway ILS system, the instrument landing system, also with the stars. So we're gonna have the magnetic North Pole heading of the runway 14 of Lszh airport in Switzerland. 136 degrees, and we're gonna align this way with the ILS localizer. We're gonna use the horizontal localizer and vertical glide slope for alignment. Final approach, we're gonna use 25-30 degrees of flaps. Pitch side is less than 9 degrees, and airspeed like 160 or 170 knots for approach and landing. So you're gonna see all these things. So we're gonna have a complete flight plan or flight path route using the flight management computer. Also now I'm gonna use the flight management computer over here. You can see also the other panels. I will explain it with detail every system. Then we're gonna make a complete flight for takeoff, climb, cruise, and approach and landing. So we have here the index, the position. Here we can set the position, Lszh index, also our performance. We have the identity of the aircraft, the model over here. So this is the index. You can select whatever you like here or here, whatever mode of the flight management computer. So we have initialize the route. We select the route, Lszh airport, Zurich International Airport, back to Zurich International Airport. So this is gonna be origin destination. We clear over here, runway 14, both for takeoff, departure, and for landing. So we're gonna use over here departures. You can see departures arrival index. So we have the departures for Lszh. You can select whatever airport you like. Transit to Alpha. So this is gonna be our seeds, the southern instrument. You can see it says seeds over here. So seeds are the standard instrument departures over here for this route. So we have departures, arrival also. So we select the arrivals. ILS 14 over here, ILS runway 14. Insert trans Amiki over here. So we Amiki trans Negri 1 up. So this is the starter terminal, arrival waypoints and fixes over here for this runway ILS 14. So we have the route completed over here. We have the legs. We're gonna use initialize 0 fuel weight plus fuel on board. We're gonna have 0 fuel weight plus fuel on board, the cross weight for takeoff, cruising altitude, cost index, center of gravity in flight. So we're gonna use 25,300 feet, the cruise altitude, 5% of reserve fuel from the total fuel on board, and a cost index of 100%. So this will give us this information: center of gravity 28% and fuel freezing temperature in flight. So we have this route activated now. You can see the purple colors. So this is the initial climb, the seat Zui, then cruising altitude, Nigra, Mati, Famiki, Zui again, top of descent, approach and arrival over here. So we're gonna approach and arrive in this runway 14. The airport, this is the stars, the long final, so the final arrival, the approach. We have also alternate VNAV, progress, FMC communications, hold. We can hold in flight like this. Fixes and navigation radio. So this is the legs initialized, 15 degrees of flaps, center of gravity 23%, 4.25 degrees trim, takeoff 128, reloaded 130, V2 140, gross weight, takeoff gross weight. So we're gonna use this is the data we have for the takeoff and flight of the aircraft using the flight management computer over here. You can see so I'm gonna use now this information. You're gonna see the flight plan we have created in the primary flight display. We have the HSI, the horizontal situation indicator, with the graded display, and also we have the horizontal and vertical profile of the aircraft. As this flight, you can see the horizontal and vertical profile of the flight plan we created, so you can see where we are located, and also the takeoff. We're gonna use the runway, the cruise, descent, approach, landing, the flight path or flight plan or route of this aircraft. So you can see also the modes around here in the head-up display. It displays the same things like the primary flight display. So we have the airspeed selected and altitude selected, and the flight director across the purple. So we have also the flight plan here we created. You can see the first waypoint, the intercept to 1.6 nautical miles from the runway takeoff threshold. Then we have to climb through and then approach and land this way. So you will see the GPS display here with the terrain map, also the elevation of the terrain, 4,700, 1,600, maximum and minimum red. This brownish color right now. So you can see yellow, green and red color for the terrain, and also you can see blue for the lakes and the sea. So we have the flight plan here. You can see how far we're gonna fly through. From these waypoints over here, we're gonna cruise and then make a turn, then descend, approach and landing. You can see also the vertical profile. Also you're gonna see how far above the ground we're gonna be flying when we are airborne. You can see the aircraft right now is in the elevation of the airport, so we have to cross through some waypoints in flight. You can see the center. You can see also, if we look closer, you can see better view of the terrain over here with green and yellow, the mountains in front of you. We are 1,400 feet on the ground and we need to climb. You can see also the runway we're gonna use, the taxiway. So this is the GPS display. The aircraft is located right here, so you can see the other runway. So we have the display of the runways here around us, just like in the GPS display over here. You can see the runways and the aircraft location, also the taxiway. So you can see these things, also the flight plan with the purple line. You can see better maybe view over here in the plan display. So you can see we can use this runway for takeoff and for landing, and we have the purple from takeoff, climb, cruise, descent, approach and landing. You're gonna see here we're gonna cross through the Zui, then follow the Negria, then turn right to the Amiki as we fly, then again turn right to the TR Alpha, then turn left to the CI-14 over here. So I can change the range, how far away we can see. You can see some more airports around you if we look closer. So you can see the TRA, then descend C1, CI-14. This is the approach and landing through Oceanem, then the runway 14. So we can see here the information displayed, the data we have select. I did not use too many data because maybe it will make a problem in my computer. So if I load too many things, so you can see all this is for navigation purposes, the flight plan. We have also here the airspeed, as I told you, indicated. The airspeed selected from the barometric altitude above the sea level. The airspeed selected from the autopilot flight director system panel. The barometric altitude, the target altitude selected. The radio altitude above the ground. The pitch slightly decrease. You can see 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 degrees for pitch up or pitch down. The nose of the aircraft. So you can see also the vertical rate indicator, vertical speed indicator. You can see how fast you climb and descend in thousands of feet per minute. So you need to pay attention to that because you might have a positive pitch attitude in flight, but the aircraft might be actually falling down. So you have also the takeoff go around, also here the flight mode annunciator, the Mazzetta line. So we have the barometric pressure setting right now is 29.92 inches of mercury, and the radio altitude 200 radio minimums. So you set the barometric pressure altitude for the barometric altitude of the aircraft, barometric in inches of mercury or hectopascals, radio minimums for approach and landing the plan and the range. Also you have traffic weather radar terrain on the navigation display. You can see more information. I will show you also here the engines, left and right engine information later. Fuel on board, the flaps position, horizontal trim, stabilizer, landing gear, external track, parking brakes, standby display, autopilot flight director system panel. So very important. We're gonna see the airspeed, the heading, vertical rate of climb, descent of the aircraft, altitude. Select all the information about the autopilot. The thrust levers over here, the flight controls. So I will show you now the flight controls of the aircraft. I will explain you what we do with the flight controls. I use the side stick to control the flight controls of the Boeing 787-900 aircraft. So I'm gonna start maybe showing you here. We have the horizontal trim stabilizer that I was talking to you before. So you can see here we can trim the horizontal tail of the aircraft down and trim up using the horizontal tail of the aircraft to trim up or trim down the whole tail of the aircraft. So it creates an aerodynamic force that pulls up or pulls down the tail of the aircraft through the center of gravity. So you need to do that manually. Over here we will display here the position of the horizontal trim stabilizer. You can see 4.25 degrees stabilizer trim, the rudder trim also. So this is the whole tail of the aircraft, left and right. You can trim up and down in flight. Make also turns in flight. Use the side stick to control it. For the elevator section, if you don't want to trim the whole tail, but I guess you have to. So you use the horizontal trim stabilizer, trim switch. We have also the head-up display, the clutter switch. Over here you can see horizontal trim stabilizer. So this is the autopilot disconnect, disengage switch, elevator trim, left click, down, right click. So this is the elevator. As you can see, the horizontal elevator of the aircraft and the head-up display. So this is part of the flight control system. As you can see, I'm gonna show you all the flight controls now. So we have the autopilot flight director system panel. Also has the fly-by-wire system of the aircraft. We have auto trim. If you have failure of the L2 and R2 or either one, L2 or R2 hydraulic system, You come here and open these red guarded seats for all Boeing aircraft, Boeing 737, 747, Boeing 757, 767, 777, from normal to cut off the horizontal trim stabilizer of the auto trim system. So you will lose the auto trim, the automatic trim. You can have the manual trim all the time. Normal pits up and pits down the horizontal tail of the aircraft like this. And also this is the alternate. We have also the parking brakes here. You can set the parking brakes up and down. We have the mouse pad here. You can use the mouse cursor. You can see in the displays here. We use the mouse to change the view here or select something. So we use the manual trim all the time. We lose the automatic trim from the aircraft. So now I will show you a few more parts of the aircraft. I will show you actually all the systems of the aircraft in the cockpit, how you use the Boeing 787-900 in flight. Then I'm gonna make an engine start demonstration. I will shut down the engines and restart them, and then we're gonna make a complete flight from takeoff, climb, cruise test, and approach and landing. So stay with me until the end part of the video to see the complete flight of the Boeing 787-900 jet aircraft. So I'll talk to you now about Newton's physics, aerodynamics, aerospace engineering. So I'll show you how to apply the Newton's physics, aerospace engineering, aerodynamics to derive some principles about flying either any aircraft. So we need for the air transport pilot license. So you can see here we have the wings of the aircraft hold the weight of the aircraft as it flies forward, so it has the thrust from the engine to push it forward, give propulsion. You can see also we have the horizontal and vertical tail to create aerodynamic effects using also the flight controls and the ailerons and the spoilers and the flaperons and the wings. So we have the mean aerodynamic chord position is 23% of the Mach, is the position where the maximum aerodynamic lift occurs in the forward wings. Is the position where you calculate the center of gravity over here approximately for an airliner aircraft. Is the position where the stall will be keen. It's gonna be over here. The earth will become detached from the top surfaces of the wings as we fly. So you need to monitor the stall speed as I told you here. You need to have an airspeed above the stall speed all the time in flight. So you can see we have we can trim the horizontal tail also. So we have the axis, the lateral axis from wingtip to wingtip, the longitudinal from nose to tail, and the vertical through the center of gravity. All these balance the aircraft using the thrust vectors from the engines. Also you can see the wings. The bottom surface of the wings using Bernoulli theory of fluids is more flat, and also we have the curvature from the flaps. So as the aircraft accelerates for takeoff, the airflow is moving much slower below the wings, which pressurizes the aircraft weight and wings up into the air. We have higher air pressure because the airflow is moving slower below the wings. Also you can see the top surface of the wings, it has higher curvature as we fly. So the airflow is moving much faster above the wings, which creates an air gap above the wings, a lower pressure, which sucks the aircraft wings and weight up into the air as we fly. So this is the basics. You have also the spoilers here, the speed brakes, and which can use also as flight spoilers. You can change direction, make left and right turns. So I will show you the flight controls right now of the aircraft. And then the autopilot flight director system, panel thrust levers, and the engine's indication. So we have a few more minutes for this to start the flight. So I will show you now the flight controls of the Boeing 787. How I use the side stick over here to control the flight controls. So I use the side stick to control the horizontal tail, the elevator of the aircraft of the Boeing 787 to climb and descend the aircraft, also make turns left and right. I use the ailerons and the spoilers using the control wheel, also the flaperons, and I use the rudder pedals for the vertical tail rudder, directional control in flight, young control. For nose wheel steering the ground, we have the tiller and the nose wheel interconnected in the rudder pedals until some airspeed like 70 knots. We have the rudder activated like 45 knots. Using the rudder pedals is aerodynamically active during takeoff from 45 knots, and the nose wheel is becoming inoperative above 70-75 knots because it's decreasing from a deflection of 76 degrees down to like 7 degrees and 0 degrees. So we have, as we accelerate for takeoff, then we have so we have all these things. We have also the toe brakes in the rudder pedals. So we have the horizontal trim stabilizer over here in the side stick, and I have the thrust levers. We have also the flap and the slats and the speed brakes. So you can see this handle also we use over here for flaps and slats position. You can see how many degrees we can move up and down, like 5, 1, 15, 20, 25, 30 degrees here. The speed brakes also externally tracked, now is extended, so you can see the flaps position also. You can see the flaps are fully extended here, left and right, and the slats also in the speed brake. So also, you know, I use the side stick for controlling flight controls of the Boeing 787. So I have this side stick here. You can see I can use it to climb and descend like this. I can use it also to make turns left and right. Maybe we need a little bit better view. So this is climb descent, make the rudder pedals, nose with steering, so we can use either one. Only elevator for climb descent. We can use only ailerons and spoilers if we use also the rudder pedals. We have the nose with steering here, the tiller, the thrust levers over here. So you can see the thrust from the engines over here, this indication. So you can see both sides are interconnected, move together in flight, the captain and the first officer, unless we have some failure during the flight. Unlike the Airbus, we have the side stick priority. So you can see also we have also this side view. So also the outside view of the Boeing 787-900 flight controls, the side stick deflection. I use the side stick to control the yoke of the Boeing 787. So this is an Airbus side stick you can use for climb descent like this. You can see make turns to the left, make turns to the right. You can see the flight controls. You can leave neutral also, use the rudder pedals, the horizontal trim stabilizer. We have the Boeing over here. So we have also the thrust levers. You can see the thrust levers over here going forward and aft. So you move forward or aft the thrust levers like this. So you can climb, you can descend using the elevator, make turns left and right using the ailerons and the spoilers and the flaperons, and use the rudder pedals. So we have coordinated flight controls, very easy for the jet aircraft or any other aircraft. So we have over here, you can see, so we can climb, you can descend, use the horizontal tail for that, the climb and descent, use also the rudder deflection, left and right, ailerons and spoilers also, left and right turns. So you can change direction, make left and make right turns like this in flight, and climb descent, rudder, deflection, and elevator, very important for climb descent usually, mainly the elevator, and the horizontal trim stabilizer. So maybe you can see better. So this is the elevator, horizontal tail. So this is all the flight controls of the Boeing aircraft. Now I'm gonna show you the rest of the systems inside. Have a few more things to see. So this is the basic lessons for the flight controls of the Boeing 787. Now I will show you also the engines, the autopilot flight director system panel, the engines, and we're gonna make an engine start demonstration. Also I will show you the overhead panel. So that was the basic lesson for the flight controls. You can see side stick deflection is proportional to the yoke over here deflection. So I'm gonna show you now autopilot flight director system panel settings, thrust levers first. Maybe I'll show you. You can see we have the thrust levers, left and right engine. We have the auto throttle disconnect switch. You can press the switch, disconnect the auto throttle. As you can see, auto throttle disengage, take off ground, thrust reverse. We can see fuel control for the left and the right engine. You can turn on and off the fuel control, cut off or on. Left and right engine, fuel fire extinguishers, pull out and switch, rudder, also transporter and rudder trim here. So this is radio and communication panel here for the Boeing 787, as you can see. So we have after the overhead panel after the engines. So the thrust levers, you move forward, you move aft. You see the indications here displayed. You can see we have the N1. You can see the N1, which is the low speed starter sub low pressure compressor. One of the turbofan puts it in the idle position. You can see the commanded now position is going up. You can change indication how much you wish. You have the takeoff limit, the green limit here, 100.4%. So this is the low speed starter sub low pressure compressor, and one of the turbofan turbojet engine, left and right, the exhaust gas temperature per engine. Parking brake set, all the doors open, doors open, landing gear extended retract. So we have some other warnings here in fusions. So we have the N2. Which is the high speed starter shaft, the high pressure compressor turbine of the turbofan turbojet engine. So you see the turbofan engines, the thrust levers, you move forward like this, you increase the engine's indications. We have the warnings now that we're not configured for takeoff. The red warnings. So this is the high speed shaft, a high pressure compressor turbine of the turbofan turbojet engine, the fuel flow per inch per hour. 1000 kilograms, 1000 pounds. You can see red, green, yellow limits not to exceed, takeoff, total air temperature, fuel, flow per engine per hour, oil pressure, oil temperature, quantity and vibration of the N2 stage of the engine. Also here we have in the overhead panel, I will show you the cabin pressurization, the outflow valves, so they're in the auto. We have pressurizer from the engines to supply the cabin pressurization system. Also some other system, the hydraulic fluid over here, pumps and tanks, the engine driving and the electric driving. You can see need had also the wing and engine gadgets and air conditioning, ventilation and oxygen regulation. Need bleed air pressurizer from the engine series, and also we have the bleed air. It indicates here cabin altitude. You have the outflow valves in the manual position. So also as this fusion cabin altitude auto, outflow valve forward and outflow valve aft, And now we have the outflow valves position. We need to position them manually. We have the rate of climb. Differential pressure can go up to 7.8 or 8 psi in flight. And when we reach 40,000 feet or 12,000 meters, the cabin should be reached 8,000 feet or 2,400 meters landing altitude. So this is the cabin pressurization. Indications: we have also the gross weight of the aircraft, 357,000 pounds, total fuel on board 34.4. The fuel temperature, below which minus 37 in freeze at radiator temperature. So we can see some systems here before making the engine start demonstration. We have here landing gear. You can see external retract, use this handle. Alternate gear, we have a gear failure and lock override, retract and extend speeds, standby display, instruments, also auto brakes here. You see set parking brake set and auto brake. It will display as rejected takeoff auto brake RTO. If we move it to the RTO, we can use it for landing also. So this is the main indications from the engines. They are supplied from the FADEX. The FADEX are the full authority. This is electronic control computers. One installed per engine gearbox, dual channel redundancy, one channel feeds the other, takes over, control monitors and displays all the engine data. You see the upper and the lower ACAS and the indication controller system display, all the multifunction display like TN1, which is the low speed sub-low pressure compressor turbine of the turbofan engine, the exhaust gas temperature per engine, the N2, which is the high speed the high pressure compressor turbine of the turbofan engine, the fuel flow burns per 1,000 kilograms or 1,000 pounds of the personal temperature or quantity, the vibration of the N2 stage of the engine. Also the outflow valves from the 5th and 9th stage of the starters of the turbofan engine. We have the GNX engines installed on Boeing 787-900 aircraft, which are turbofan engines, one left, one right, infrastructure per crossing medicine. So also we use the outflow valves to supply with pressurizer from the 5th and 9th stage, and also from the bypasser for cabin pressurization, wing and engine anti-ice, air conditioning regulation, oxygen regulation in the cockpit and the cabin, and also for the hydraulic fluid tanks pressurization. So the flight controls, you see I'm moving here using the side stick. We have, or the yoke, we have fly-by-wire, electric deflection control, electric control of the fly-by-wire system, horizontal trim stabilizer, the tail. So you see all here, the tail, the rudder, iron spoilers, everything is moving hydraulically. So we have electric control by hydraulic power system over here, which needs also pressurizer from the engines. Also we need the APU here, pressurizer. We cannot turn the APU, it's a smaller turbine in the tail of the aircraft in order to start the engines in a cold and dark aircraft. I will show you how to use it. It's a backup turbine in the tail of the aircraft to provide electric power and pressurizer. So we need all these systems. We need also the FADEX control, the full authority electronic control computer, source control, fuel flow to the engine, fuel metering unit, pressure inside the engine, overpressure, under pressure, can open and close the outflow valves into higher or lower position. Also the fuel heat exchange sensors and oil heat exchange sensor. We have the recirculation of the fuel from the fuel tanks, left and right wing and center tank, into the engine's components using the fuel recirculation system in flight, because in the altitudes we fly the fuel might be freezing, like minus 37 degrees. We're gonna have freezing fuel, so we recirculate all the time to duct heat from the engine components, also cool down the engine. Also we do the same for the lubricant, the oil. We have also, as we climb the aircraft from the sea elevation or the airport elevation, all the way up to like 20,000, 30,000, 40,000, like 8,000, 9,000, 10, 11,000, 12,000 meters above the sea level. As we climb higher and higher, like 40,000 feet, 30 or 40,000 feet, uh, the pressure of the air, the density of the air, and the oxygen level become less than half than that of the sea level. Also, as we climb higher, the aircraft will be flying with an airspeed rate like 2 or 3 times faster than that of the sea level. So we have a higher intake of air from the front fans of the engines for compression and fuel mixer. Also, the temperature becomes freezing, like -30, -40, -50, -60 degrees zero. So we need below zero. So we need Celsius degrees below zero. So we need a different fuel mixer every second. This is adjusted automatically using the FAREX. Also, as we descend back to the airport from the cruise level. So it's a good thing to have the FAREX to control everything into your engines. We have now the autopilot flight director system panel. Just 1 second over here. I'm gonna make the settings. So you can see the autopilot engage, disengage, auto throw, left and right, flight director, the LNAV and the VNAV here. You will display something. So we have auto throw like this, on and off, flight director off. If we turn off flight director, we cannot rearm the modes from the autopilot. We need flight director on all the time. So this might arm 1 or 2 modes. We have the flight, the airspeed, select knob, climb continuous, auto throw, LNAV, VNAV, later vertical navigation, flight level change, autopilot disengage, bank angle in flight. Also the magnetic north pole heading of the runway we're gonna use here. So this is the autopilot panel, very important. I'm gonna use 136 degrees. The altitude, cruise altitude here. I'm gonna use thousands. Then hundreds. So we have also the vertical speed here. We can set a descent like this, or climb the other way. So you can climb the aircraft like this, descend, heading, airspeed guidance, auto throttle, autopilot, engage, disengage, altitude, roll localizer, and approach for autobahn. So this is very important. You see now all the values are changed here in the primary flight display. 253, 25,300. So we have the overhead panel. We need to start the engines. I will explain you some systems. We have here the APU. We need to start very quickly. Use some lightings also outside to see what's going on. We have the primary flight control computers in the auto position, air data computer heading a reference, GPS receivers, laser gyroscope. So this is the air data computer that displays pitot airspeed and dynamic altitude, static pitot tube for airspeed and altitude difference, and also radio altitude, magnetic heading, laser gyroscopes, alignments, magnetic north pole. So it's everything inside here. The air data computer, flight control surfaces, battery, towing power, FD door, passenger oxygen, window sheet. So rammer turbine, the hydraulics. We turn off the hydraulics, you will see what happens. Primary demand like this. Then we turn them on. From the fault it will show us some indications. So we have the wing and engine radius here, on and auto, very quickly. So this is the lighting also system, the windshield wipers, the hydraulics I show you. This is the recorders, the cargo and APU fire, electronic engine control for the engine, left and right engine with the auto start position. Fuel jettison, you can dump some fuel in flight. If you want this, select the nozzles also, how much to remain. Fuel on board, left and right wing tank, center tank, crossfeed valve. You can use the crossfeed valve to feed either engine with either pump or either tank, also to balance the fuel between the left and right engine, left and right tank. We have also the cabin pressurization, the bleed air from the packs from the engines and the APU. Cabin pressurization in the manual use also valves climb descent. Automatic, you leave the way it is. It's all controlled automatically. So this is the overhead panel just before I make an engine start demonstration. We need only one last thing here. The displays here, systems. So we have the systems in electronic format. Everything is in the overhead panel. Hydraulic, APU, oxygen, liquid cooling, the electric, left and right engine, high disease grade dry generator, 130 to 100 volts, 400 Hz frequency. The APU is running. The battery, main battery, and APU battery, the voltages. So we have the hydraulic, where the hydraulic fluid goes, the demand in the primary, engine drive and the electric C1 and C2, the pressure 5000 psi, fuel left and right, wing, fuel tank, center tank, how much fuel you have, 11,000, 11,000, 11,000, total 73.9. Land high pressure fuel valves, left and right engine, open feed both engines, cross feed valve is off, but we can alternate on feed either engine with either pump or either tank. The APU is fed from left when using this motor. We have the fuel booster pumps forward and up. Also here very important, the minimum fuel temperature below which the fuel is freezing, minus 37 degrees in flight. So we need to recirculate the fuel to the engines automatically. Oxygen regulation and air conditioning, doors are closed, the cabin can be pressurized. The gear, you can see the temperature of the brakes and the pressure of the tires, the nozzle also. Flight controls here, you can use the flight controls. You see this is working over here, the tail for climb descent, so it displays here flight controls, the tail also, climb descent, make turns, horizontal trim stabilizer. This is how much it deflects. F is display, maintenance, is digital also, so you get breakers digital, and also checklist, last thing to do before flight, normal menu, before takeoff, after takeoff, descent, approach and landing. We'll go back to the ND. So we're gonna start the engines. We're gonna turn them off first, here. So I turn both fuel control to the off position, like this. As you see, we have both engines off, are slowing down right now, and some systems are coming up. We have the warning that the engines are off. So we're gonna see the hydraulics also turning off. So we have the engines auto start here. We turn both on. We're gonna have the automatic reset, everything in number, all lights in the overhead panel. So now we have pressurizer from the engines. You're gonna see above 20% we can start. We have pressurizer. We can start the fuel control now. Turn on the fuel, left and right fuel control. Fuel valves on. So we have the auto start is kicking in right now, as you can see, both left and right engine. We're gonna have a lot of pressurizer like this, all the systems auto start, as you can see, and the amber indications, the occasions are going off because the systems are resetting, restart. So we have running both engines left and right with green. We can go now for takeoff. So we advance the flaps for takeoff, parking brakes off, and we're gonna use this takeoff view. We have only to taxi into the runway. So we start the taxi now into the runway for takeoff, advance the thrust levers. so the runway is open for us. We take the clearance from the air traffic control. So let's align with the runway heading over here. This is the tiller for alignment. So we're gonna use maximum takeoff thrust like this, as you can see over here. So we are ready for takeoff. We have 100 knots, aligned with the rudder pedals. V1, V rotate like this, so slight rotation. We have some side wing. So we keep climbing. We had something like must be like a stall, or I don't know, maybe a wind shear, because the aircraft dived and I could not pull it up. So that was a wind shear, a very strong one. So we are above 2,400 feet above the ground. The airspeed now is 230 knots on the altitude 4,500 feet. We're climbing 3,500 feet per minute. So we can see also from the outside view over here. A beautiful view of the Switzerland. So we need to accelerate now for the climb altitude. You can see also the terrain in the displays over here, and now the engine display. You can see how far above the ground we are. So we have 15 more minutes for this flight. So we need to accelerate to higher airspeed. We track maybe some flaps. So we have also the display. You can see here the France, the Germany, the Bayern Munich, my homeland, the Germany, the Switzerland. So we're gonna start making a turn now. to cross through this waypoint here, the Zui. We need to follow the flight plan lines, and we have like 13 more minutes for this flight video to end. You can see the follow of the Zui, the waypoint here. So we need to turn now to the next waypoint. So we keep climbing, and we have 11 more minutes for the flight to end. You can see the airspeed here, the stall speed, the indication, the airspeed, and the flaps, the rate of climb here, the altitude, the rate of climb, the terrain, and the flight plan, the cruise level that we're cruising right now, the engine's indications here, the autopilot here, flight director system panel, and the head-up display. So we have the outside view, beautiful view of the lake, the Germany in front of you, the Bayern Munich, the France, the Galaxy also, and the Swiss Alps. So we need to start the turn now, back to the airport. So make manual flight, like this. So this is the turn over here, 22,900 feet, and we cruise through the lake here, the Germany, Bayern Munich, my homeland, the France, and the Switzerland. So this is the Boeing 787, 22,300 feet. You need also some right rudder over here. Keep climbing. And we have 9 more minutes left for this flight, approximately. We have beautiful views here. Need to follow also the flight plan. So we are aligned with the flight plan right now. And we need we're gonna see some vapors from the engines, and then we need 8 minutes. So we're gonna climb through a little bit higher, 25,000. So we're gonna have the chemtrails 36,000 feet. We're gonna see, you can see the stall speed marking. We have rates over here. Now we're gonna have the chemtrails created. So we're gonna see the frozen vapors for a few minutes. Then we're gonna start the descent back to the cruise level. So we have the frozen vapors over here. You can see the galaxy also. So this is 26,300 feet. We have the frozen vapor from the Boeing 787. Beautiful display. Then we need to go back for landing. So we leave a beautiful view, the Germany and the lake behind us, and the France, and we're going back for landing right now. So we need to descend fast. Idle thrust. Also flaps completely retracted. Accelerate a bit faster. As we descend. So this is the view of the cockpit from this altitude. We need to follow here the flight plan. As you can see, indications. So we increase the rate of descent. We need to descend higher rate. And we have 5 more minutes left for this flight over here. For approach and landing. So 5 more minutes. We're gonna see how we're gonna approach over here. I'm gonna start the turn now for the final approach. So we have the runway this way, as you can see. So we need to enter here this flight path. We have 4 more minutes for the landing. So we need to align with the runway. We need to slow down also, as you can see. So we need to pit stream a little bit the aircraft right now as we are descending. And we have 3 more minutes for approach and landing over here. So we are here, this altitude. Also gonna have this view. For the landing indication. So we're gonna use a few more flaps, more idle thrust as we descend, and we have 2 more minutes for the landing, as you can see. So we are in a very good position for alignment for landing. Over here is maybe we have no worry about the video time. We're gonna make it no matter what. We're gonna land. So you're gonna see the landing over here of the Boeing 787. Maybe we need to increase the rate of descent, so we need to align. We use all flight controls, as you can see, of the Boeing 787, ailerons, spoilers, rudder pedals, the vertical tail, also some thrust. We need a little bit more power now. Align with the runway. We have some side wings, so we need to balance the aircraft with the aerodynamic of the wings around us. So here we are. We have the flare over here, flare for landing. So we flare the aircraft align with the runway. Touchdown. So we have a beautiful touchdown and flare. So parking brakes and idle thrust over here. So made a beautiful landing. Now align with the rudder pedals with the center line. So we slowing down, full thrust reverse and parking brakes. So you can see we just made a very beautiful landing over here. You can see all the landing gear, all the parts are perfectly safe. Over here you can see both our landing gear behind and the nose wheel. There is no breakage of any part. So the aircraft is standing up the way